last few times. I usually do the speaking, but Jason is going to speak, and he's a better speaker than I am. I want to welcome Jason for being willing to come to small town Weirton and speak to you guys. He's going to speak on astronomy, but he has some talks on logic, on how to defend the Bible, presuppose the Bible to be true for valid reasons. And those talks, you may want to look up the website. I guess you have it on icr.org. Those talks are really great. I had to listen to it about 5-6 times before I could grasp most of it. But that will revolutionize the way you defend the Bible, and we should all be defending the Bible, because when you try to present the gospel to somebody, they're going to have a lot of questions. And if you are doing that like Jesus says that you should, you will have a lot of questions that you can't answer. So you come back and look at resources. That's why we have these Worldview Series. It's mostly scholarships associated with that for high school and college students. But it also is for the general audience, because we all are supposed to want to care enough about other people to defend our faith and to preach the gospel. Jason worked initially with Answers in Genesis and now works with Institute of Creation Research. And a lot of good research material is coming out of there. You have the magazine out there, Free Acts and Facts, and you go to their website to get a lot of good information. And Jason is the Director of Research at ICR, and there's a lot of other credentials which would take about an hour to read. But he's a great speaker, and he has a love for the Lord, and he's going to come and speak to you about this. He'll stay back, answer questions. Sometimes, if the talk is long, we sometimes take a 5-minute break in between, so I'll leave that up to your discretion. A 5 or 10 minute break, and then answer questions, and you can talk to him after the session's done. And tomorrow morning also he'll be speaking at Mercy Baptist for the morning service, about 10:30 or 10:45, I believe. So welcome, Jason, come up.
Well, good morning, folks. It's really good to be with you today. Really appreciate Dr. John having us out here, and always a pleasure to come back east. And I grew up in Ohio, so it's always fun to come back to this part of the world. And I want to talk to you today about astronomy, because astronomy is one of those areas where people try to use it to challenge the Bible. Isn't that right? They'll say, well, we know now that science has proved, that Genesis isn't true, and there's a Big Bang and so on. In fact, there's a series that's going on now, the Cosmos series with Neil deGrasse Tyson, and he's really used it to try and as a propaganda piece against Scripture. And that's really a shame, because God made the universe to declare His glory, and not to challenge Scripture, but to confirm it. And so I want to show you today that astronomy, when you understand it, it really confirms that God's Word is true. And there are 5 secrets of the cosmos we're going to look at today, 5 areas of knowledge where the Bible got it exactly right. We're going to talk about the glory of the Lord being revealed in the heavens, and we're going to find the Bible got that right. We'll talk about the basics of astronomy, things that you'd learn in a freshman level astronomy class, and we're going to see that the Bible got that right. We'll talk about the age of the universe according to Scripture, and we'll take a look and see that the scientific evidence confirms the Bible got that right. We'll look at the uniqueness of the Earth. Is the Earth just a pale blue dot, like Carl Sagan used to say, or is it a special world? And we're going to find the Bible got that exactly right. And then we'll even talk about distant starlight. How did God get the light from those distant galaxies to Earth in the biblical time scale? And there are several ways to do that, actually. So let's go ahead and start with talking about the glory of the Lord. The Bible says that the heavens declare God's glory, and there's a couple different ways in which they do that. But we read that in the 19th Psalm, that the heavens declare the glory of God, the skies proclaim the work of His hands. And I'm going to argue that there are at least 2 ways in which they do that. I'm going to argue that the beauty and the size of the universe confirm God's glory. Of course, there are many other ways the universe declares God's glory, its power, its majesty, its clockwork precision. We're just going to look at just 2 for the sake of time. And we'll see that the universe really does declare God's glory. Let's start with the size of things, and I like to start with the moon, because that's relatively small. We can kind of get our heads around that. The moon is about the same size as the United States. If you were to put the United States up at the same distance as the moon, it would cover the same area. That gives you kind of a feel for how big it is. And I love looking at the moon through a small telescope. I was doing that just a couple nights ago. I had my telescope out, and it's really, really just beautiful. It's a magnificent desolation. One of the astronauts who walked on its surface referred to it as that. And given how big the moon is, people sometimes ask, because I'll do these viewing sessions where they'll come and look through the telescope, and they'll say, well, can you see the flag, from where the astronauts landed? Well, no, considering it's the size of the United States, you can't quite see the flag. But believe it or not, we have spacecraft orbiting the moon right now. We have a spacecraft that's going around taking high-resolution images of the surface, and it can see where the astronauts landed. Isn't that interesting? And so we've been able to get very high-resolution images of the surface of the moon. And you can see, for example, here's the Apollo 11 landing site. That's a real image. And you can see, remember when they took off, they left the bottom portion of the lander, like that spider-looking structure, to save fuel. They just used the top portion. So the bottom portion's still there, and along with some other equipment that they left on the surface. And you see that faint line that extends over there? That's the footprints of the astronauts as they walked over to that crater and back. So 40-year-old footprints, and they're not going anywhere. There's no weather on the moon, so they'll be there for quite some time, actually. So isn't that amazing? I just always thought that was just one of the most amazing achievements that human beings have done. And of course, it's only possible because the Lord upholds the universe in a consistent and logical fashion that obeys math. And so by understanding math, we can do some amazing things. So pretty neat. And so for those people that think that we never landed on the moon because you saw a special on Fox, well, it's all Photoshop. The scale of the universe is just as amazing as its beauty. And so keep in mind, we'll start with the moon, about the size of the United States compared to the Earth. The Earth is just beautiful from space. One of our speakers at ICR, he's an astronaut, and he's been in 3 space missions already, and he's taken a bunch of pictures. Colonel Jeff Williams, he's taken a bunch of pictures of the Earth. He says it's just beautiful from space, and we know that. We've seen pictures of that. But the Earth is small potatoes compared to Saturn, for example. Saturn is about 9 Earths across, and that's just the planet. The rings extend out much further. Those rings are trillions of tiny little moonlets that orbit around Saturn's equator. And astronomy is such a lesson in perspective, because if you look at Saturn through a small telescope, it's beautiful, but it's tiny. It's this little gem there. You just want to pick it up and stick it in your pocket, But it's a massive world. What a lesson in perspective, the way things seem versus the way they really are. Saturn's small, though, compared to the Sun. The Sun is about 100 Earths across. It's basically a stable hydrogen bomb, producing more energy every second than 1 billion major cities would use in a year. Just an incredible source of power. The Sun is what we call a main sequence star, and so that itself is kind of amazing, that those little pinpricks of light you see out there, those are like the Sun. And the Sun is kind of an ordinary run-of-the-mill main sequence star. There are stars that are smaller than the Sun, red dwarfs, for example, and they're maybe half or a little bit less the diameter of the Sun. But there are stars that are bigger and brighter than the Sun. For example, blue supergiants like Mintaka. This is one of the stars in Orion's belt. And you can see it's quite a bit larger than the Sun and much more luminous, much brighter than the Sun. We can see Mintaka in our night sky, but if we went to Mintaka and looked back, you would not be able to see the Sun because it would be too faint. So it puts out an incredible amount of energy. We have white supergiants like Canopus. You can't see that from Pennsylvania, but if you come and visit us in Dallas, you can see that because it's pretty far south. It's kind of below the Earth's equator. And but even more massive stars like Antares or Betelgeuse, for that matter. These things are just enormous. They're red supergiants, and they're it's about 600 suns across. And the Sun is 100 Earths across, and so if you multiply that out, it's really big, really big. Some stars are kind of by themselves, like our Sun is, and some come in clusters. And some of my favorite objects to look at in the night sky are they're called globular star clusters, like M80 there. And it's just a beautiful collection of stars, really amazing. We estimate there's maybe 100,000 stars in that cluster. And it reminds me of that verse where it says that God calls them all by their names. God has a name for each one of those stars. Isn't that just amazing? Some of the most beautiful objects in the universe, they're called nebulae, or nebula singular, And it basically is cloud. It's a cloud of hydrogen and helium gas. And that's the same stuff that stars are made of, the two lightest elements, hydrogen and helium. But whereas stars are compact, only a few hundred suns across, something like that, a nebula is spread out over a vast region of space. And so you can see there are actually several stars within this nebula. It's that big. And stars, if they're nearby the nebula, they'll heat up that gas and cause it to glow, and you get beautiful, beautiful colors in these nebula. They're really stunning. Some nebula are large, others are relatively small, only the size of maybe our solar system, which is small compared to the rest of the universe. And these small versions are called planetary nebulae, because some of them look kind of round, like an out-of-focus planet, but that's the only connection there. And some of them have this two-lobe structure. You see that? It's got sort of those two lobes, and we think that there's probably a disk around the star that channels the material out the north and south poles of the star. They call that a bipolar planetary nebula. And other ones are round. And it could be the ones that are round are also bipolar, but maybe we're looking right down the axis. That's a possibility. We don't really know. We can't get another angle on it. One of my favorites is called the Ring Nebula, and it's kind of what it looks like, doesn't it? And this is the first that I learned how to find in a small telescope, and it's just right in between two stars near the star Vega. And it's a beautiful image in our summer night sky. You just need a small telescope to be able to see it. It's not difficult at all. Now, you won't see the colors in a small telescope because when you're using your night vision, it's grayscale basically, but it'll look like a grayscale version of that. And it's beautiful. And it's so weird too. Most of the places you point a small telescope, you just see stars and stars and stars. And that's beautiful, but they're just stars. There's this one magic little spot where you will see a glowing smoke ring. And it's just so strange. It's this little cosmic Cheerio suspended on nothing there in space. You're sort of expecting it to expand, and it doesn't. But it is expanding. It's just so huge you don't notice it. Really beautiful. All of these stars, all of these nebulae, all of these star clusters are in a much larger structure called a galaxy. And they used to think that our galaxy, the Milky Way, was the entire universe. That was it. They could see these other galaxies, but they didn't realize that these were like ours. They thought maybe they were small and within our galaxy. And now we know that these are massive collections of literally hundreds of billions of stars. Yeah, like the Whirlpool galaxy that you see there. Really amazing, stunningly beautiful. All kinds of galaxies out in the universe, galaxies of tremendous beauty. There are galaxies of tremendous ugliness. There are galaxies that have large, mysterious arrows next to them. You'll see that in all the textbooks. They're always pointing to something interesting, too. There are galaxies that have rings of stars surrounding them. How about that? There are galaxies that look like flying saucers. That's a real galaxy. They call that the Sombrero Galaxy, and you can see why. It's got that dark dust lane that blocks the light from the stars behind it. There are galaxies in the process of collision. That's kind of interesting. Of course, the distance between the stars is so enormous, the two galaxies would just pass through each other. There'd be no collisions. It'd be very unlikely for any two stars to collide. Going deeper into space, you find galaxies sometimes come in clusters. How about that? So every one of those little fuzzy things you see there, those are not stars. Those are galaxies with hundreds of billions of stars each. Amazing. Going even deeper into space, galaxies upon galaxies. That's not a star field. That's a galaxy field. Okay? There are a few stars. Now, of course, we're in a galaxy, and so we have to look through ours to see the other ones. And so some of our own stars get in the way. But you can spot those because of the spikes on them, like that one right there and that one there. Did you know stars have spikes? Well, they don't really have spikes, but the way the Hubble takes the images, the stars end up looking like that because they're point sources. But all the rest of these are galaxies, each one with maybe 100 billion stars. And we estimate there's at least 100 billion galaxies in the universe. That's amazing. All this spoken into existence by God. All this made according to Scripture in 6 days. In fact, most of this was made in 1 day, because if you read the Genesis account, 5 of the 6 creation days, God's working the earth, making it right for life. He takes 1 day, day 4, and makes everything else, the entire universe, almost like an afterthought. And I love the way the Bible describes the creation of all these hundreds of billions of galaxies with hundreds of billions of stars each. It's summed up in this little phrase, He made the stars also. Like an afterthought. You know what would go good with this earth that I'm going to make? How about 100 billion galaxies? Let's throw that in too. Why not? People say, why would God go to all that trouble. Hey, it's not trouble for God. He's an infinite creator. It's no more difficult for him to make the entire universe than just the earth. Well, the universe certainly declares God's glory. It's not an accident. It's not a big bang. It's the glory of God. What about the basics of astronomy? Things that you'd learn in a freshman level astronomy class? You know, the Bible's right about those too. And today we'd have to agree that the Bible got it right, even though when these statements were made, not everyone agreed. So the Bible's been vindicated. Let me give you some examples of that. The spherical nature of the earth. The Bible describes the earth as being like a circle, or in other cases it describes God inscribing a circle on the face of the waters at the boundary between light and darkness, which indicates a spherical world, and not as opposed to a flat dime or something like that. And of course the world is spherical, we know that. We got pictures of it from space today to demonstrate that. And those statements, you might think, well, that's obvious, but those statements were written at a time when not everyone agreed with that. Isaiah is 700s BC. Job, we think, is around 2000 BC. But even by the 500s BC, the Greeks were just starting to realize the earth was round. In most astronomy textbooks, they will credit Pythagoras with being the first person to come up with the idea that the world might be round. Aristotle's considered the first to demonstrate that the world is round. But they're late to the game, because the Bible is talking about the roundness of the earth long before the secular experts of the day figured it out. By the way, the idea that Christopher Columbus was the first to come up with the idea that the earth is round is a myth. People already knew the world was round at the time of Columbus. He just thought it'd be faster to go that way. And it turns out he was wrong. So anyway, people have known the world is round since ancient times. Earth is suspended in space. God hangs the earth upon nothing, according to Job 26:7. It's a wonderful description of the nature of gravity. God literally hangs the earth on nothing. What a great description. Might have been hard to believe when it was written. Again, Job 2000 BC, but even by 800s and 900s BC, the early Greek experts taught that the world was a flat disk and floated in water. And wouldn't that make more sense? Because after all, we know some things float in water. That I've seen, but to suspend something on nothing, to hang it on nothing, that makes no sense. I wonder if it was tempting for the Hebrews of that time to say, well, you know, I know the Bible says that God hangs the earth on nothing, but the best experts tell us, hey, it floats in water, and that makes more sense to me. I'm going to believe that. I don't know. I mean, I just wonder if that happened, because we certainly see that kind of thinking today, don't we? The expansion of the universe. The Bible teaches that God stretches out the heavens as a curtain, spreads them out as a tent to dwell in, it says. And again, that might have been hard to believe when it was written, because up until the 1500s, most of the secular experts thought that the universe was static and eternal and unchanging. And so the idea that it's getting bigger or expanding would have been maybe a little bit hard to believe. After all, you can't really see that. It's not obvious. You go out tonight, the universe looks about the same size as it did last night. It's hard to tell that it's being expanded. It wasn't until really the 1920s that astronomers came along, Hubble and others, and realized from observations from measuring redshifts of galaxies, it's as if the entire universe is being stretched out or expanded. Everything's moving away from everything else. And so the Bible got it right thousands of years in advance, thousands of years before the experts of the day confirmed it. Now some people have said, well, does this mean that there's a Big Bang, Dr. Lisle? Because after all, if you get all these galaxies, you know, moving away from each other, does that mean that the universe exploded into existence 13 billion years ago? And the answer is no. Just because something's getting bigger doesn't mean it exploded into existence, right? I mean, some of you are getting bigger. It doesn't mean you exploded into existence billions of years ago. It just means you're bigger than you were yesterday, but no. And some people have said, well, doesn't this at least count as evidence for the Big Bang? Because didn't the Big Bang predict that the universe would be expanding? And lo and behold, there it is. No, it's not a prediction of the Big Bang, because the Big Bang, the expansion of the universe was discovered in the 1920s. The Big Bang, the idea that the universe came from a point, was invented in 1931 as an explanation for the expansion. It's not a prediction. It's post-diction. It came afterwards, you see, as a secular explanation for it. No, this doesn't in any way prove a Big Bang. It just means that God apparently made the universe pretty big, and then He's stretched it out since then. It's not a problem for God. Conservation of energy and mass. There are principles in physics, conservation principles. Basically, the amount of stuff in the universe is constant. You can't create brand new energy. You can't destroy energy. You can transform energy from one kind to another, but the quantity always stays the same. And likewise with mass. Einstein tells us energy and mass are basically the same thing, measured in two different ways. We'd expect this from Scripture because the Bible indicates that all things were made by God, and God ended his work by the seventh day. And so that means we'd expect nothing new would come into existence, right? Because it would mean either God is still creating, which cannot be because he ended his work of creation by the seventh day, or it would mean that stuff can come into existence apart from God, which cannot be because all things were made by him. Now, does this mean that God can't do a creative miracle? Well, of course not. We know God can do that. This is a general trend. As a general trend, we would not expect God to be creating new material today since he ended his work of creation. And we would expect that nothing would cease to exist either because God upholds what he's made. The Bible teaches that as well. And so these two principles together, nothing disappears and nothing comes into existence. These two principles together are conservation of energy and conservation of mass. And it's sort of hard to pin down when the secular experts discovered these things, but usually James Joule is credited with the discovery of conservation of energy anyway, and he's 1800s. So again, the Bible discusses these things long before the secular experts of the day, and we'd have to agree the Bible got it right. The Bible got it exactly right. Countless numbers of stars. The Bible uses the stars of heaven along with the sand of the seashore as a metaphor for an uncountable, a humanly uncountable number. Of course, we know God counts the number of stars and has a name for every one of them. But human beings, we couldn't do that. And that's a great analogy, although it might have seemed like an only so-so analogy when it was first written, because naked eye, you can only see, we estimate maybe 10,000 stars if you have superb vision. And if you have average vision, maybe about 3,000 stars. That's a big number, but it's countable. And then, of course, we invented telescopes, and we pointed them out, and we realized, oh, that cloudy band that you see, that Milky Way, that's not just a cloudy band, that's billions of stars. We estimate there's between 100 billion and 400 billion stars just in our galaxy. And you couldn't count that in your lifetime. You couldn't do it. You don't live long enough. It's a great description of an uncountable, a humanly uncountable number. Wonderful analogy. So the Bible got it exactly right, even though the experts of the day might have said, well, that's not so good of an analogy. Do you get the point? Have we learned the lesson of history? Have we learned that when the Bible touches on a topic, it's right? Even if that topic seems trivial or even if it's a matter of science. I know the Bible's not a science textbook, but when it touches on science, it's right. Because after all, the Bible's inspired by God. God knows how the universe works. He made it after all. He upholds it. And so when the Bible touches on a subject, it's right. Even when the experts of the day have disagreed, they now have egg on their face. The Bible's been vindicated. They were disproven. That's always the case with God. God has yet to lose an argument. So, what about today? Have people learned the lesson of history today? And I'm sad to say that not everyone's learned that lesson of history, because you got people today who say, well, the Bible's wrong about this. We know from science X, but the Bible teaches Y. Well, one of those issues is the age of the universe, isn't that right? Because you'll learn in the secular school system, for the most part, they'll teach that the universe is billions of years old. And of course, I realize that we have some Christians in that system, missionaries in a pagan system. I'm grateful for that. But for the most part, that's what they teach, isn't it? Billions of years. And but what I want to show you is that the evidence is actually consistent with what the Bible teaches. What does the Bible teach about the age of things? The Bible teaches that God created in 6 days. It's clear from context those are ordinary, approximately 24-hour days. Perhaps some of you have heard that, well, in Hebrew that could mean a long period of time. Well, it can't in the context of Genesis. That's a myth that keeps going around. But whenever the word yom, the Hebrew word for day, is used with a number in an ordered list, or when it's used with evening and morning, that constrains it to an ordinary day. And so there's no doubt that God created in a week. Created in 6 days, rested 1 day. In fact, that's the basis for our work week. If you read in Exodus chapter 20, verses 8 through 11, verse 8, remember the Sabbath day to keep it holy, and he explains in 6 days you'll do all your labor, but the seventh is the Lord's. In verse 11, he gives the explanation for why you're to do that. He says, for in 6 days the Lord made the heaven, the earth, the sea, and all that is in them, and rested the seventh day. Therefore he blessed the seventh day and hallowed it. And so if God had created over millions of years, we'd have a really long work week. You'd never make it to the weekend, literally. No, it's very clear. By the way, it uses the same Hebrew word for day for our work week and the creation week of God. So no, it's very clear. God created 6 days, and we know from those genealogies that you love to read before you go to bed, and so begets so-and-so. You know, you read those. It'll help you sleep, really. But those verses are there for a reason. They tell us that Genesis is real history, and by adding up the ages of the patriarchs and so on, you can get a time scale, something like 6,000 years between creation and now. Maybe you can't get an exact date, but it certainly wouldn't be millions or billions of years. And that's something where the secular scientists say, no, the Bible's wrong about that. We know the universe is much older. What I want to show you, though, is that the evidence, the scientific evidence, is consistent with what the Bible teaches, not the story that the evolutionists teach. For example, the excess internal heat of the giant planets. Jupiter gives off twice as much energy, twice as much heat as it receives from the sun. And you can't do that forever, right? It's giving away twice the energy that it takes in. You can't do that indefinitely. You can't keep spending more than you take in, right? We're not the federal government, after all. We can't do that kind of thing. But anyway, Jupiter is going to eventually run out of energy. And if it were billions of years old, it should have already run out of energy. Kind of like when you take a potato out of the microwave and it's nice and warm and it's radiating that heat into space. It doesn't stay warm very long, does it? You can't just live on that heat. You can't just say, well, I'm just going to heat up the potato and that'll be my heat source for the winter. It doesn't work. It's going to cool off. Now, Jupiter is a much bigger potato, and so it can do that for a lot longer, but it can't do it for billions of years. If it's 6,000 years old, not a problem. It's, after all, 10 Earths in diameter, 10 to 11 Earths in diameter. It hasn't run out of energy yet. It's still quite warm. Likewise, Neptune. Neptune gives off 2.7 times as much heat as it receives from the sun. And why is it still so warm, relatively warm, if it's billions of years old? I submit it just hasn't run out of energy yet. Earth's magnetic field. The Earth has electrical currents in its core, and that whenever you have an electrical current, that generates a magnetic field. And the Earth's magnetic field is, it surrounds us, protects us from solar radiation, for example. But that magnetic field is decaying because electrical current encounters resistance, and as that resistance, it slows down the electricity, and that basically causes our magnetic field to be reduced with time. And we've been able to measure that for almost 2 centuries. We've been able to measure the drop in Earth's magnetic field. It's an exponential decay as far as we can tell. Now, we think during the flood year, there's good evidence that the plate tectonics would have disrupted Earth's magnetic field, causing rapid reversals. But that's not something that's happening today, because there's no worldwide flood today. There's no geological activity that would cause that. So, but that just drains the strength even faster. So before the flood, it was just an exponential decay. Today, it's an exponential decay. And if you run the movie backwards, if you go back even 50,000 years, the magnetic field would be, I believe it's 56 billion times stronger than it is today, which would rip your atoms apart. So the Earth can't even be 50,000 years old, let alone millions or billions. It can't even be 50,000 years old. And likewise with some of the other planets of the solar system, some of them have magnetic fields too. Jupiter's is much stronger than the Earth's. And so it's amazing that it would still have that strong magnetic field if it were billions of years old. Magnetic fields decay with time. They just do. And so it just can't last that long. The magnetic fields of the planets Uranus and Neptune are quite strong, and surprisingly so if they were billions of years old. In fact, a friend of mine, Dr. Russ Humphreys, he's a physicist and a Bible-believing creationist, and he actually was able to predict the magnetic field of the planet Uranus before it was measured by the Voyager spacecraft. And he was able to do that because he believes in 6,000 years. He said in 6,000 years, the magnetic field should have decayed to this amount. So this is what I predict Voyager will measure. Voyager flew past and it measured that magnetic field for Uranus. The evolutionists were way off because they thought the magnetic field would be gone by now if the planet's billions of years old. And they've tried to, and by the way, Russ Humphreys hasn't just predicted Uranus, he also did it for Neptune, and in fact, his model explains the magnetic field of all the different planets in the solar system and their moons, and he gets the right answer. It's really interesting. It's not surprising if you understand that he starts from Scripture, and that's why he gets the right answer. The magnetic fields of the solar system are consistent with thousands of years. Now, my secular colleagues say, well, there must be some kind of dynamo process that's recharging that magnetic field, reviving it, making it new. But one of the predictions of that magnetic dynamo model is that the magnetic field should be aligned with the rotation axis, or at least pretty close to it. And you can see with Uranus, it's not even remotely close. The rotation axis is here, the magnetic axis is there. It's very different. In fact, the magnetic axis doesn't even go directly through the middle of the planet. So it's like a big bar magnet stuck in the side there. And Neptune's is that way as well. So I'm going to suggest that these are just evidence of thousands of years. The recession of the moon. The moon is actually moving away from the Earth due to tidal forces. You might know that the moon causes tides. Its gravity pulls on Earth's oceans. And then those tidal bulges get ahead of the moon because the Earth rotates faster than the moon orbits. So the Earth's doing that and the moon's orbiting slowly. So the tidal bulges are always ahead of the moon, pulling forward on it. And the counterintuitive part is what happens when you pull forward on something in orbit? It moves out. That's a little bit strange. But when the astronauts want to go into a higher orbit, they thrust forward, and that kicks them into a higher orbit. And then again at apogee, and then that stabilizes it. So if you run the movie backwards, the Earth and Moon would have been closer in the past. And if you run, it turns out if you run the math backwards, and you have to do the math properly because you have to use calculus to do it, because the Moon, if it's closer to the Earth, the tidal bulges are bigger, and so it goes even faster, and they get even bigger, and it goes even faster, and it dives into the Earth in 1.4 to 1.5 billion years. And that may sound like a lot, but in the secular view, the Earth-Moon system is something like 4.5 billion years old. But you see, it can't be that old because they would have been touching at 1.4 billion years. Now, it's not a problem for biblical creation because if you run it back 6,000 years, the moon would have been about 730 feet closer to the Earth, 730 feet. Not a big difference considering it's 240,000 miles away. Comets are made up of icy material. They orbit around the sun in elliptical paths. So you have this ball of ice and dirt way out here, and then it comes close to the sun and gets slingshotted back out. Okay, now think about that. When you have ice and dirt close to the sun, well, the dirt's not a problem, but the ice, problem, right? Because that solar heat is going to heat up the ice and vaporize it, and that's what forms a comet's tail. That's actually the comet losing mass. Every time you see a comet, it's getting smaller. It's losing material to space. And we can calculate the rate. We can measure the rate at which that material is leaving, and we know the size of the nucleus of a comet. It's only a few miles in diameter generally. And so you can estimate that the typical maximum lifetime of a typical comet is about 100,000 years. And so if the solar system is 6,000 years old, it's not a problem. We should still have some comets here and there. But if it's billions of years old, why do we still have comets? And again, this is a typical number. Some of them don't last that long. There are comets. I used in my PhD research, I used the SOHO spacecraft, and one of its functions is it can actually look for comets when they get very close to the sun. It's hard for us to see them because of the glare of the sun, but SOHO is designed for that. And so I've seen comets that go behind the sun, and that's it. They're totally destroyed in one pass. Maybe you heard about comet Ison last December that came very close to the sun, and it didn't survive. Some of its material came out the other side and dispersed into space. It's gone. There is no more comet Ison. And so the fact that you still have comets demonstrates that they don't last millions or billions of years. I mean, the solar system is thousands of years old. Comets just can't last that long. And we have these spiral galaxies. Galaxies that are spirals, not all of them are spirals, but the ones that are rotate differentially, meaning the inner portions rotate quick and the outer portions rotate slower. And so if you think about that, the spiral structure would get tighter and tighter with time, wouldn't it? It's constantly wrapping itself tighter. And I've actually done a computer simulation of this to see what galaxies would look like if they were as old as the secularists say, and they don't look anything like that. They're twisted beyond recognition. They don't even look anywhere close to a spiral galaxy anymore. And so the fact that you find these spiral galaxies with these fairly loose arms is an indication that they're not even hundreds of millions of years old. It's certainly consistent with thousands of years. You might notice the bluish tinge to these spiral arms. See how they look a little bit bluish like that? That's because the arms have a higher proportion of blue stars in them. And blue stars are themselves an indication of the youth of the universe because blue stars are the most luminous stars in the universe. They expend their fuel very, very quickly. They're also the most massive stars, so they have the most fuel available. They're kind of like the SUV of the star world. They have a big gas tank, but they get very poor gas mileage. And so they can't last very long. They can't last even, the brightest, bluest stars can't last even like 1 million years. And yet we find them everywhere in the universe, especially in these spiral galaxies. And so that is an indication that the universe isn't that old. So certainly the Bible's right about the age of the universe, and there are lots of lines of evidence that indicate that confirm the biblical age. What about the earth, the uniqueness of the earth? According to the scriptures, God formed the earth to be inhabited. It's a very special place. It's the place where God himself became a man, died our death on the cross, and so on. In the secular view, the earth's just, hey, a pale blue dot, right? That's how Carl Sagan put it. Well, in Scripture, it's very different. It may be small physically. It may be a pale blue dot in terms of its size and compared to other things in the universe. But God formed it to be inhabited, the Bible says in Isaiah 45:18. And so it's a very special world. And it's not like the other worlds in our solar system. The moon, for example, the moon's beautiful to see in a small telescope, but it's a magnificent desolation. It's just a cratered, barren surface. There's no life there. You couldn't live on the moon unless you bring a little bit of Earth with you. I mean, the astronauts were there for a short period of time, but they had a space suit that brought a little bit of the Earth's environment with them so they could survive. You couldn't live for very long on the moon even with that, because the surface temperature varies from hundreds of degrees. And so it's not designed for life. It's a magnificent desolation, to be sure. Earth's neighbors, you got Venus a little bit closer to the sun than the Earth. You got Mars a little bit further away. Beautiful planets. I'm glad the Lord created them, but they're not designed for life. They're designed to give God glory, certainly, but they're not designed for life. Now, that's not always been something that secularists believed, because in the past, there were some evolutionists, not all of them, but some of them believed that Venus might have a lot of life on its surface. It's closer to the sun than Earth. Maybe it's a tropical paradise world with all kinds of exotic plants and animals that had evolved there and so on. In fact, if you look in some of the older science fiction, a lot of those have, talk about going to Venus and there being life on Venus. I still remember an old episode of The Outer Limits. Remember The Outer Limits? And I remember there's one where William Shatner goes to Venus and he sees these weird creatures on it and so on. And it's a lot of fun, but the real Venus isn't like that. The real Venus has a surface temperature of 900 degrees Fahrenheit. So you're not going to have life on the surface. Not when you can melt lead in that kind of environment. And see, evolutionists were free to speculate because Venus is permanently enshrouded in clouds. And so they were free to speculate about what might be on the surface, unfettered by inconvenient facts or observations. But now we know what's on the surface. And we've now mapped it with a radar, and so radar can penetrate those clouds. By the way, those clouds are made up of sulfuric acid type compounds. So it's just a really nasty place to be. And you say, why would God make a horrible environment like that? Well, we're not supposed to live there, right? We're supposed to look at it in our night sky and say, wow, that's a beautiful, beautiful object. And it is. Venus is sometimes called the evening star or the morning star, depending on when you look at it. And it's stunning. It's the third brightest object in our sky. You get the sun, the moon, and then Venus. Very pretty. Those clouds that would kill you if they were there are highly reflective, and they make Venus one of the most beautiful objects in our night sky. Mars, and by the way, if you've not seen Mars before, now's the time to look at it, because every 2.1 years, Earth comes very close to Mars, and this is the month. So if you look at in the evening sky, kind of in the southeast, pretty high, that very bright, pretty reddish looking object, that's Mars. And it really is stunningly beautiful, but it's not designed for life. It doesn't have the right kind of atmosphere to support life. It doesn't have liquid water on its surface as far as we know. It's got frozen water and a little bit of water vapor, but no liquid water as far as we know. And it doesn't have that protective magnetic field that the Earth has, and so the cosmic rays would be a problem if you were going to live on Mars. That's something that we'll have to consider if we ever want to send, make colonies on Mars. You'll have to worry about cosmic radiation, things like that. Not designed for life. And so you got this one too hot, this one too cold. That reminds me of Goldilocks and the Three Bears, right? These one's too hot, that one too cold, that one's just right. And that's what we'd expect, given that God designed the earth for life. He designed these other worlds to do other things, to be beautiful and so on. And that raises a question then, what about extraterrestrial life? That's a popular topic these days. What about ETs out there in space? And of course there's programs like SETI that spend millions of dollars searching for extraterrestrial life, listening for signals from space. They haven't found any. I don't think they will. And I'll grant that the Bible doesn't directly say one way or the other, but I would be surprised as a creationist if they did discover life in space, given that God formed the earth to be inhabited, and space is designed for other things, not to be inhabited, but for other reasons, to declare God's glory and so on. And of course, if you have intelligent life out in space, there's going to be some theological implications you're going to have to think through, right? I mean, if you got Vulcans and Klingons out there, they can't be saved. Did you know that? The poor Klingons are out of luck because, you see, the reason we can be saved is because Jesus is human. He took on our nature, and we're of one blood, the Bible says. He's our kinsman redeemer, and that's why his blood can atone for us on the cross. And that's why animals can't atone for sin. Now, they were used symbolically in the Old Testament to point to the Redeemer to come, but they're not related to us, you see. And so it's because Christ is our blood relative that he can redeem us. But Lieutenant Commander Worf is out of luck because he's a Klingon and he's not related to Jesus, so he can't be saved. And so as entertaining as I find things like Star Trek, I find that the real universe isn't that way. Just that it wouldn't make sense. There's some theological issues there. People say, well, wait a minute, maybe Christ went to the Klingon homeworld and became one of them and died for them too. No, because the Bible says he died once for all, right? He's now and forever the God-man, not the God Vulcan or the God Klingon. He's human from now on. He's God and human. So, amazing. But then it's interesting because my secular colleagues actually have a problem when it comes to extraterrestrial life. It's called the Fermi paradox. Fermi was a scientist. He was very brilliant, but apparently not a creationist, because he would have known the answer if he'd have been a creationist. He was asking, where are they? Why isn't that his thinking was as follows. He thought, well, if life on Earth is just a chance accident, which apparently he believed, and it's a big universe, and it's been around for billions of years, which he believed, then life probably evolved elsewhere too. And statistically, it's inevitable that in some places it would have evolved before it evolved on Earth, which means those life forms would have already become advanced and have colonized the galaxy. But the galaxy isn't colonized, is it? We don't see any evidence of life in our galaxy besides Earth. So where are they? That was his question. And that's called the Fermi paradox, and it has never been resolved in the secular worldview. But in the Christian worldview, it's not a paradox at all. It's exactly what we'd expect, isn't it? So, yeah, not a problem for the biblical creationist. Earth is unique. It's special, and science confirms that. What about distant starlight then? I want to take some time on this issue because it's a puzzling issue. The question is, how is it that we're able to see these galaxies that are very far away? We know what the speed of light is, and in secular thinking, these galaxies are so far away that it should take light billions of years to get from there to here. Now, light's very fast. Don't get me wrong, 186,000 miles per second. Very fast. But these galaxies are very, very far away, such that even at the speed of light, it would take, theoretically, billions of years to get from there to here. And yet we see these galaxies, which means the light has gone from there to here. And so you'd be inclined to draw the conclusion, well, the universe must be at least billions of years old. And we know from Scripture that's not the case. And of course, we know from other science that's not the case as well, as we pointed out. So what's the solution then? I want to very briefly just point out some solutions that I don't think work. And I do that because otherwise people will come up and say, well, have you considered this? Yes, we've considered that, and it doesn't work, and here's why. I just want to briefly touch on that. One is that the distances aren't real. People have said, well, maybe the galaxies really aren't that far away. Maybe they're all really, really close, but that just isn't feasible. The methods by which we measure the distances of these galaxies are good methods. They're good scientific methods. They're not based on evolutionary assumptions or anything like that. And they put the galaxies at tremendous distances. And that's one of the ways the universe declares God's glory, is by its incredible size. Or maybe the speed of light was much faster in the past. And that was a very good thing to postulate, to hypothesize. But we've tested that hypothesis, and it looks like there's really no compelling evidence that the speed of light has ever been anything different than what it is today. When you look out into deep space, apparently light travels at the same speed there, and so on. And so I'm not convinced that there's good evidence for that. But it was a good thing to try, because sometimes rates are different in the past. And if you don't know that, you get the wrong answer for age. One of the more popular ones is maybe God made the light already on its way. Maybe when God made the star and the earth, he connected them with a beam of light. And at first, that sounds kind of good, doesn't it? Because there are some things that would work for. I think when God made the first trees, they probably had rings already in them, because that's part of the structure of the tree. And you'd say, well, don't rings indicate years? Well, they do today, but not for the first trees. Okay, that's part of the structure of the tree, and you might think, well, light's like that, but there's a difference when it comes to light. And so I don't think this is the right answer, and here's why. Light in transit requires God to create fictional images and movies. And let me show you what I mean by this. We have here the supernova 1987A. So in the year 1987, in one of the Magellanic Clouds, which is it's a satellite galaxy that's orbiting our galaxy, there are two of them, and in the Large Magellanic Cloud, there was an explosion, a supernova, 1987A. So a little blue star right there blew itself to bits. And today it looks like that. You can see the expanding star guts, basically, spreading out into space, okay? And that galaxy is 179,000 light years away, which means in secular thinking, the event actually happened 179,000 years ago, and the light finally arrived in 1987, okay? But if you say, no, I think that God just made a picture of the explosion, well, then that means that this star never existed, and this explosion never happened, and this doesn't exist either. These are merely pictures that God put in a beam of light about 6,000 light years out that finally arrived at the Earth in 1987. So light in transit would mean that none of these things have ever actually existed. And by the way, we get not only light from this, we got neutrinos, these subatomic particles that travel at nearly the speed of light. They arrived at Earth too. And did God make a beam of neutrinos on the way too? This view that God created the beams of light already on their way would indicate that about 99% of the universe is fiction. It's just a convenient fiction that the Lord created for us. And now the question is not, does God have the power to do that? Of course He's got the power to do that. That's not the issue. The question is it consistent with His nature to do that? And I don't think it is. God's not the author of confusion. He made our senses to be reliable. So I don't think that He would make beams of light with fictional images and movies in them. And if you say, well, no, I think God might do that. Well, be careful, because how do you know I'm here right now? Right? I mean, if God is willing to make fictional images for 99% of the universe, why not the remaining 1%? You say, well, we see you. Well, maybe God's just making the beam of light 1 inch away from your eye, and so on. That's why you're getting the image of me, but I don't even exist. Right? You say, well, we hear you too, Dr. Lisle. Well, that's no problem. God's making the sound 1 inch away from your ear. You see, maybe you're just a brain in a jar. Well, God could do that, but in terms of having the power, but I don't think it's consistent with His nature to do that. So that's why I don't think this is the best answer. And there are better answers. Dr. Russ Humphreys has an interesting model. I think this turns out not to be the right model, but I wanted to mention it because it's at least plausible. We know from Einstein that time can flow at different rates in different environments. And Dr. Humphreys has proposed that the Earth is in a gravitational well such that only a few thousand years elapses on Earth while a lot of time passes in the rest of the universe, or at least the further out you go, the more time passes. And that is plausible. I haven't seen a version where the mathematical details actually work, though. And I've been pushing Dr. Humphreys to do that. He's a friend of mine, so we can push each other on that way a little bit. I think the answer may involve the one-way speed of light. And this is a little bit complicated, so put your thinking caps on, and we'll try to deal with that and get some feedback here. Not sure why. Okay, there we go. The one-way speed of light. Most experiments that measure the speed of light are what we would call a round trip, or a two-way speed of light, not a one-way speed. And let's imagine how we might measure the speed of light. We'll get a very long hallway. Let's say it's 186,282 miles long. I'll pick that distance because it makes the math work out easily. So we're going to build this very long highway, 106,000 miles long. We'll pretend we have government funding. We can waste it that way. And at one end over here, we'll have a clock and a flashlight. And when the clock strikes noon, we'll turn on that flashlight just for an instant, and that'll send out the light pulse. It'll come out, bounce off the mirror, and come back. And we'll have somebody standing over there, and when he sees the reflection, that's when the light returns, is when he sees the reflection, he'll look at the clock, and we'll find if we do that, 2 seconds will have elapsed every time, because the speed of light is constant, we say. It always travels at that speed. So, and you divide it, the distance is 186,282 miles, but it has to go there and back, so it's twice that, and it takes 2 seconds to do it. So the speed of light is 186,282 miles per second. Now, a lot of people assume that it took the light the same time to go out as it did back. In fact, I've pictured it that way. There, 1 second to go out, 1 second to come back. But we don't actually know that, right? It could be the case that the light zips out, maybe taking no time at all to get there, and takes all of 2 seconds to get back, you see? You'd see the same thing, wouldn't you? Because we can't be here, there, and here at the same time. We're not omnipresent like God is. We're over here, and we see the light come back, 2 seconds. You don't know that it traveled at the same speed. Or maybe it takes all of 2 seconds, maybe it takes all of 2 seconds to get out and then zips back instantaneously. That could certainly be the case, theoretically. And people would say, well, why would the speeds be different? And I don't know, but I don't know why they'd be the same either. There are certain crystals where the speed of light is very different in one direction in the crystal than it is the other direction. It could be the vacuum of space is like that. It could be the speed of light's different in one way than the other. And you say, well, I want to believe it's the same both ways. Well, that doesn't make it so, though, does it? Right? We need to be scientific about this and not make just assumptions based on our preferences. And people say, well, does it have to do with the mirror? Is the mirror slowing it down or speeding it? No, it has nothing to do with the mirror. In fact, you could put another flashlight here. You could have your buddy standing over here, and when he sees the first pulse, he fires back the return pulse. I'm suggesting that perhaps the vacuum of space is such that the speed of light is different in different directions. And it could be, for example, that when light is directed toward you, it travels instantaneously, providing that it travels at half c, half of 186,000 miles per hour on the way back. And you'll get exactly the same answer. Exactly the same answer. That would be consistent with all experiments that we've done, interestingly. But that doesn't mean that that is the case. I hope you see where I'm going with this. If it's the case that light travels instantaneously when it's moving toward you, then there is no distant starlight problem. Because the light from the galaxies does not have to make a two-way trip. It doesn't have to come from the Earth and then go out and then bounce back. No, it only has to go from the galaxy to here. It's a one-way trip. And if the speed of light is instantaneous when directed toward an observer, which it could be, then the distant starlight problem is solved. But again, we don't want to base it on wishful thinking. We want to measure it. Is the one-way speed of light different than the round-trip speed of light? And so how would you do that? How would you measure the one-way speed of light? Well, you can't use a mirror anymore because we don't want to do a return trip. We just want to measure it one way. And so we'll have a clock. We'll now have to have a second clock over here, right? Because we need one clock to tell it when to start the flashlight, and we need another clock over here to detect the light and read off the time. And you might think, well, yeah, that'd take 1 second, right? This clock is noon. This clock reads the time. It ought to be 12:00:01. Well, in fact, I did this in my office. I don't have a long hallway, but I have the distance between my watch and my phone. And as soon as my watch hit noon, I turned on the light, whatever hit the phone, and I read off the time on the phone, and the phone said 12:05. And I said, oh, light takes 5 minutes to travel from my watch to the phone. Is that right? Something's wrong there, right? But I really did that experiment. I really did that. Noon to light, when it hits the phone, 12:05. You say, well, Dr. Lisle, obviously the two clocks are not synchronized, right? This kind of experiment would only work if the clocks are synchronized. And by the way, they have to be exactly synchronized because we're measuring something that's very fast. Light, whatever it is fast. And so they have to be exactly synchronized in order for this kind of experiment to work. Okay, no problem. We'll make sure the clocks are synchronized. That turns out to be really hard to do. Normally the way it's done is a radio transmission. In fact, my watch actually will do that. When it actually receives a radio signal from Fort Collins, Colorado. They have the atomic clock in Boulder, and Fort Collins sends out a radio pulse. Maybe some of you have clocks that do that. They synchronize themselves to the atomic clock. And the way that happens, the Fort Collins sends out, at midnight, it sends out a radio signal, and then it comes over and my watch sets itself to midnight as well. Now, are they now exactly synchronized? Not exactly. Not exactly, because radio takes a little bit of time to travel from this clock to this clock. Now, radio is fast, but it's not instantaneous necessarily. And so you might say, well, how fast does radio travel? How long does it take radio to get from there to there? Do you know how fast radio is? Radio travels at the speed of light. But wait a minute, that's the thing I'm trying to measure. That's the thing I don't know, right? The one-way speed of light. If I don't know the one-way speed of light, I don't know the one-way speed of radio either. You see, if I knew the speed of radio, I could subtract it off. I could push that clock a little. I could say, well, I know the signal took some time to get here. I'll push the clock 1 second forward. But if we don't know the one-way speed of light, you don't know the one-way speed of radio. You see the problem? Some people have said, well, maybe if we put the radio transmitter in between the two of them, that'll settle it. But there's a problem here, right? Because you say, so you put the radio here, and it sends out the signals. You put it exactly in between the two, and so they'll be synchronized to the same time. Maybe they're both behind the radio a little bit, but that's okay. They're synchronized with each other. That's all you need. But the problem is that assumes that the speed of light, and therefore the speed of radio, is the same in both directions. If it isn't, then that one gets set to noon first, and that one gets set to noon later. And they're not synchronized. You see that? I know it's kind of dark on the screen there, but that one gets set to noon, and then that one gets set to noon. And so there's a 2-second difference, actually. So you see that you cannot exactly synchronize clocks by radio transmission without already knowing the one-way speed of light, so you can compensate for it. One last possibility. People have said, what we'll do is we'll put the two clocks in the same place and we'll synchronize them. That you can do because you can look and see that they're synchronized, right? There's no distance between them. And then we'll move one of them or both of them to the opposite ends of the hallway. The assumption being that the clocks will remain synchronized when you move them. But Einstein says, no, the very act of moving the clocks causes them to become desynchronized. Motion affects the passage of time. We don't notice that in our everyday lives because it's a tiny effect. But it's a real effect, and it causes it has been measured with atomic clocks. We've flown atomic clocks around the world, and lo and behold, the time slows down a little bit. So it's, now there's an equation that tells you how much this clock will be behind this clock, or how much the time is affected, depending on how fast you move it. So maybe we can compensate for it, but there's a problem. In that equation is the one-way speed of light. Yeah. So in all cases, are you getting the picture here? In all cases, in order to synchronize these two clocks, you would have to already know the one-way speed of light in advance to make sure they're synchronized. But if you knew that, you wouldn't have to measure the one-way speed of light. You see the problem? We're stuck in a permanent catch-22. Apparently, it's impossible to synchronize clocks without knowing the one-way speed of light, and you can never measure the one-way speed of light without synchronized clocks. Isn't that interesting? I mean, it's just intellectually fascinating to me that the Lord has constructed the universe in such a way that it is impossible to measure the one-way speed of light. I find that just amazing. Now, I find that up to this point, most people say, okay, I can kind of see that, or maybe you're thinking there's some experiment that could do it. Well, I can tell you, physicists have been trying for 100 years, and none of them have been able to do it. Apparently, it's impossible. The next step, though, is where people say, what do you mean by that? I'm going to draw this conclusion. I'm going to draw the conclusion that the one-way speed of light is a convention. It's not a property of nature at all. When there's something that you can't possibly measure it without first knowing it, that suggests that it is not a property of nature, but is a convention. Convention is something that we all decide what it is. We all agree to it and it works. Driving on the right side of the road is a convention. We all agree to it and it works. But of course, you go to a different culture, you go to Australia, they all agree to drive on the left side of the road and that works. A convention is something that you could choose it and you could choose it to be different. And as long as everybody agrees, it works. 12 inches in a foot. Why are there 12 inches in a foot? What property of the universe causes there to be 12 inches in a foot? Well, nothing. People decided there should be 12 inches in a foot, you see. The one-way speed of light is like that. We get to decide what it is, and then that tells us how to synchronize our clocks, you see. And then when you go, now that you have synchronized clocks, now you can measure the one-way speed, and it will be whatever choice you assumed. If you do the math right, if you do your experiment right, and you're consistent, you can choose the one-way speed of light, and whatever it is, your experiment will confirm that that's what it is. Isn't that interesting? And it's counterintuitive, I know, because we think, well, it's either this or that. If only God would whisper into our ear what the one-way speed is. But in fact, it's like inches in a foot, or which is this table 3 feet long, or is it 1 yard long? Which is it, 3 or 1? Well, in order to answer whether it's 3 or 1, we're going to have to pick a unit. If you pick feet, you get 3. If you pick yards, you get 1. You see what I'm saying? And so, which is right? Is it 3 or 1? Well, it depends on what unit you want to pick. And so it is with the one-way speed of light. Is it the same in all directions? Could be. Is it different? Maybe it's instantaneous. That could be it too. You get to choose, interestingly. And so we select, and normally what is done is they'll assume that the one-way speed is the same in all directions because it makes the math easier. And I have no objection to that. You can do that. That's legitimate. So if a bolt of lightning strikes and two observers at A and B see the blast, it's reasonable for them to say, we're going to call that noon, okay? And that's fine. But you could choose any other convention too. You could make it instantaneous this way and half C that way. As long as the round trip speed averages to C, you're good. The round trip speed of light's set by God. You can't change that. The one-way speed, we get to pick. That light requires the same time to traverse the path A to M as for the path B to M is in reality neither a supposition nor a hypothesis about the physical nature of light, but a stipulation which I can make of my own free will in order to arrive at a definition of simultaneity. I get to pick the one-way speed, and that tells me how to synchronize my clocks. That's a quote by Albert Einstein. Einstein knew this principle. This principle is called the conventionality of distant simultaneity, the conventionality, or the conventionality thesis. And you can look up articles on the internet if you want on the one-way speed of light. There's even, believe it or not, there's even an accurate Wikipedia article on the one-way speed of light. That's it's pretty good, actually. I don't remember, I wouldn't trust Wikipedia, but I can assure you that that particular one is accurate. So I'm free to choose the speed of light to be infinite when it's toward me, toward the observer, and you can do it toward you. The speed of light's infinite when it's moving toward you, as long as it's half c when it's away from me, because you got to keep the round trip speed c, and that will average correctly. Now, why would I pick this convention? Aside from the fact that it solves the distant starlight problem, right? Because if the speed of light's instantaneous when it's toward me, there is no distant starlight problem. But there's another reason why I would pick this convention. All ancient cultures used this convention implicitly. They did not subtract off the light travel time. They didn't know what the round trip speed of light was. And so when you see something happen, that's when it happens. Okay? And so it's very reasonable to use this convention, and we still use it today. For example, when I mentioned supernova 1987A, the naming of that supernova is using this. It's based on when we see it. They didn't call it supernova 179,000 BC. They called it supernova 1987, because that's when you see it happen. They're using this convention. And it's a very convenient convention. It's one all ancient cultures use, and I believe it's the one the Bible uses. Yes, I believe it's the one the Bible uses. So if that's the case, then light takes no time at all to get here from distant galaxies if the Bible uses this anisotropic synchrony convention. Anisotropic means different in different directions. Anisotropic synchrony convention, or ASK. Does the Bible use ASK? I think so. For one, the Bible was written to be understood by everyone, not just 21st century physicists, right? And so it's going to use a convention that would have been understood at all times. And only the anisotropic synchrony convention would have been understood at all times. When you see something, that's when it happens. That's a very reasonable and intuitive convention. It's the Einstein convention that is not intuitive. I see something happen, but it really happened a long time ago. That's counterintuitive, isn't it? I don't think the Bible would use that particular thing. But also, I think it's suggested in Genesis. Take a look with me here in Genesis 1, 14 and 15. God here says, "Let there be lights in the expanse of the heavens to separate the day from the light. Let them be for signs and for seasons and for days and years." And we read on it, he's talking about the greater light, the lesser light, the sun and the moon, and the stars also. Okay, so the stars are these lights that God put in the expanse of the heavens. "And let them be for lights in the expanse of the heavens to give light on the earth." And it was so. What was so? They gave light on the earth. Apparently, when God first created the stars, they immediately gave light on the earth. And that would imply the ASK, the anisotropic synchrony convention. God creates the stars, their light instantaneously falls on the earth. And you might say, well, intuitively, I don't like that convention, but the fact is you can't disprove it. In physics, the ASK convention is a perfectly legitimate convention, and it takes light no time at all to get from distant galaxies to the earth using that convention. And so I think that's a pretty good solution to the distant starlight problem, if indeed the Bible uses ASK, which I think it does, based on Genesis 1:15. So we've seen that the Bible is right when it talks about the glory of the Lord being revealed in the heavens. It's right when it talks about the basics of astronomy. It's right when it talks about the age of the universe. It's right when it talks about the uniqueness of the earth. And it's right when it talks about distant starlight, regardless of whether or not I came up with the right answer or not. I mean, there's some things that we're not going to have scientific details on. I don't know the scientific details of how God raised Christ from the dead, and I'll probably never know that. But that doesn't mean that he can't do it. God is not limited by our conception of what's possible. And that's something we need to keep in mind. Even if, if somebody just ends up disproving my model for distant starlight, that's okay. God can be God. He can do things the way he wants to. It's not a problem. But there are known ways to resolve that issue, and I just gave you one. So we have some resources that I encourage you to check out. We have my book, Taking Back Astronomy, which covers a lot of this information. In fact, this talk really is based on the book. That's the book that you want to get to go along with the talk. And some people have thought that it's a children's book because it has lots of pictures in it and everything, but it's not. It's for grown-ups. But my thinking is grown-ups like pictures too. And the universe is beautiful, so why not showcase that? Stargazer's Guide to the Night Sky. This is not an apologetics book. It's just a book on how to better enjoy the night sky as a Christian. And I loved writing it. I love looking at the night sky. And if you ever want to know, where can I find Mars this time of year? Or where's Jupiter? And what's that constellation? And so on. It's got beautiful full-color star charts to tell you how to find these things. You say, I don't have a telescope, no problem. It shows you what you can do naked eye. Or even if you have binoculars, you can see Saturn's rings in binoculars. If you know which one's Saturn, the book will show you how to find that. So that's a nice resource that you may want to get. Created Cosmos is the planetarium show at the Creation Museum. If you haven't been there, you should go. It's a good museum. But in any case, if you can't, you can bring the planetarium show to you. And we have that on DVD and Blu-ray. And my book, Ultimate Proof of Creation, if you really want to learn to defend the faith well, this is the book that you need to get. This is going to show you how to think and argue like Christ did in his earthly ministry. And you know how the Pharisees and Sadducees would come and they try to trap Jesus, and he just turned it around on him. He just always had this brilliant answer. The book will show you how to do it. That's something we can learn, because the Bible actually tells us how to defend the Christian faith. And it's going to show you how to do that. It's a very powerful resource. A Discerning Truth, How to Spot Logical Fallacies in Evolutionary Arguments. And so when people say, well, bacteria becoming resistant to penicillin, there you go, evolution in action. You say, actually, that's an equivocation fallacy because you changed on the word evolution and so on. And so it's very powerful to learn those fallacies and to be able to spot them in arguments and be able to name them. We have Creation Basics. There's two versions of this. We have the kind of the high school version, junior high school version called Guide to Creation Basics. And then we have one that's a little more advanced. It'd be for college students or adults, or really either one would be for adults, really. But and that's Creation Basics and Beyond is the more advanced version. So I'd encourage you to check that out. And we do have a sign-up sheet if you'd like to get Acts and Facts magazine. That's a free magazine. And please sign up on our newsletter. We should have that here somewhere, hopefully. But check us out on the web, too. ICR.org is our main website. Anything we don't have here, you can get it on the website. Your Origins Matter is our student ministry. And I encourage you to check that out. Students can get on and ask questions and such, and we'll answer as many as we can. They can conversate and so on. And then I've got a blog, too, that you might want to check out as well. So thank you very much.